Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. Okay, this is a new chapter continuity. Already we have completed limits. Around 20 videos are there in the playlist of limits. You can go and check it out. So this is the first video in the chapter of continuity. First we will discuss what are continuous functions, and after that we will discuss the meaning of continuity of a function at x is equal to a. When can I say that a function is continuous at x is equal to a using this particular condition? And after that we will start solving some problems based on continuity at x is equal to a. In case if you are new to the channel, don't forget to subscribe to our channel. Let us start with continuous functions. First, let us discuss a general meaning of continuous functions. What are continuous functions? Very simple. Students, if you can draw the graph of the function, any graph, okay, now without lifting your hand continuously in the domain of the function, then those functions are said to be what functions? Continuous functions. Okay, now for example, if you look at the graph of sin x in its domain, you are drawing the graph of sin x without lifting the hand. Continuously can draw the graph of sin x. Okay, now so the graph, so we can say that y is equal to sin x is a continuous function. For example, if you take a parabola, already y is equal to ax square plus bx plus c represents a parabola. You have learned this in the chapter of quadratic expressions, right? You will draw the graph of parabola without raising the hand. Without raising the hand, you can continuously draw the graph of a parabola. So therefore y is equal to ax square plus bx plus c is also a continuous function in its domain. So in this way, if we can draw the graph of a function continuously without lifting the hand, we can say that those functions are continuous functions. Okay, fine. First, before learning how to check whether a function is continuous or not in the given interval, first let us start defining the continuity of a function at a given point. First let us see when can I say that a function is continuous at a given point at x is equal to a. So before going to that, I have shown you graphs of continuous functions. Now there are functions which are not continuous also. For example, if you look at the graph of step x, the greatest integer function, if you look at the graph will be like this, correct or not? So I cannot draw the graph continuously without lifting the hand. See, I am drawing this part, I lift my hand and then again I will draw this part. I lift my hand and again I will draw this part. The graph of step x is not continuous. Even fractional part of x. The graph of fractional part of x is something like this. If you want to draw the graph of fractional part, obviously we have to lift our hand. It is not continuous. There are functions which are not continuous and there are functions which are continuous. In this particular chapter we will be discussing about those functions. We will be discussing about the continuity of as many functions as possible. Okay, to define that, first let us understand when can I say that a function is continuous at a given input at x is equal to a. At x is equal to a at this particular point, where how can I say that the function is continuous or not mathematically? Let us see. Okay, so let us discuss about continuity of any function y is equal to f of x at x is equal to a. So when can I say that the function y is equal to f of x is continuous at this particular input x is equal to a? Let us see. Let me take a random graph. Okay, now any graph. Let us draw some function y is equal to f of x. For example, let me draw like this. So let me take any input x is equal to a in the domain of this function y is equal to f of x. For example, I'll take this input. Let that input is x is equal to a. And remember, this number a should be in the domain of f of x. Okay, now. So now at x is equal to a, dear students, if I am drawing the graph when input is nearing a, how will I draw the graph? Obviously, I am drawing the graph without lifting my hand, correct or not? Okay, geometrically I can say that the function is continuous if I can draw the graph without lifting the hand. But mathematically, how can I say that the function is continuous at x is equal to a? So mathematically, listen here, when your input is approaching a from the left side, when your input is approaching a from the left side, the function should be approaching one particular number. Okay, now let that particular number be f of a. When input is a, the output is obviously f of a only. No? So okay, let x is, when input is a, let the output is f of a. When input is a, let the output is f of a. Now when your input is approaching a from the left side, the output must be approaching the same number f of a from the left side or right side, whatever it is. And when your input is approaching x is equal to a from the right side, then also the output must be approaching the same number f of a. What is the meaning of it, dear students? It means that limit x approaches a minus f of x. What is the meaning of this? Left hand limit. When x is approaching a from the left side, f of x is approaching some number, that is left hand limit. It should be equal to limit x approaches a from the right side f of x. That means LHL should be equal to RHL, and at the same time it must be equal to the value of the function. Dear students, when input is approaching a from the left side, the output is approaching some number. When input is approaching a from the right side, the output is approaching some number. Okay, now both the numbers must be equal to what? The value of the function. The left hand limit should be equal to right hand limit. It should be equal to value of the function. It means that, once again let me write it, LHL, the left hand limit, should be equal to RHL, must be equal to value of the function. I can also write like this. LHL is f of a minus. It should be equal to RHL, which is f of a plus, and it is equal to value of the function f of a. If this condition is satisfied, then we can say that the function y is equal to f of x is continuous. The function y is equal to f of x is continuous at x is equal to a. So if left hand limit is equal to right hand limit and it is equal to value of the function, then obviously we can say that the function is continuous at x is equal to a. Okay, now see, dear students, one important note point here. If you want the limit of the function to exist, if you check that LHL is equal to RHL, it is enough. In limits chapter, we have verified only if LHL is equal to RHL. We never checked whether it is equal to value of the function or not. In limits, if you want limit of the function to exist, then if LHL is equal to RHL, it is enough. But in case if you want to check whether the function is continuous at x is equal to a or not, then LHL must be equal to RHL and both of them must be equal to value of the function. Understand the difference. To check continuity, all three must be equal. But to check whether the limit exists or not, these two are enough. These two are equal means it is enough. Okay, now fine. But every time we don't have to find LHL and RHL, right? Sometimes already like in some problems now, we don't have to find LHL and RHL separately. Directly if you check whether limit x approaches a f of x, that means if you check whether the limiting value of the function is equal to value of the function, this is enough. So in every problem we don't have to check whether LHL is equal to RHL or not. Some of the problems you will directly find the limiting value of the function. Already if you have practiced the limits chapter, you would have known in which question we have to find LHL and RHL and in which question we will find limiting value of the function directly. Okay, now here also in problems you will get more idea about it. Fine. A simple example on this continuity. A simple example, let f of x is equal to x plus 3 for all x belongs to R. For all x belongs to R. And let me check the continuity at x is equal to 2. Okay, now let us check continuity at x is equal to 2. For this, first let me find the left hand limit, dear students, f of 2 minus at x is equal to 2. The left hand limit, what is it? Limit x approaches 2 minus f of x. Okay, limit x approaches 2 minus f of x is x plus 3. And we can also convert this limit as what? H approaches 0. If I write h approaches 0, then instead of x we will write 2 minus h. Correct or not? X becomes 2 minus h plus 3. Okay, so this is limit h approaches 0. 2 plus 3 is 5 minus h. Now you can substitute h value as 0, you will get 5 minus 0 as 5. The left hand limit is 5. Similarly, we can find right hand limit, that means f of 2 plus, limit x approaches 2 plus, and here 2 plus h plus 3. So you will get 5 plus h. And if you substitute h value as 0, there also you are getting 5 only. And what is the value of the function f of 2 is equal to? Directly you can substitute x as 2 now. You will get 2 plus 3 which is equal to 5. So in this particular example, we have observed that f of 2 minus is equal to f of 2 plus, and both are equal to f of 2. All are equal to same number called 5. So therefore we can say that f of x is equal to x plus 3 is continuous at x is equal to 2. A simple example, right? Fine. Now let us start solving the problems based on continuity at x is equal to a. Let us take the first question. Here is our first question. F of x is equal to this particular function when your input is not 0, and the same f of x is equal to 1 if input is equal to 0. Okay na? So it is a piecewise function. F of x is equal to two different types of functions for different inputs, piecewise functions. Okay na? We are supposed to check its continuity at x is equal to 0. So which means I have to check whether f of x is continuous or not at x is equal to 0. Okay na? In this particular question, there is no need of finding LHL and RHL separately, because when x is approaching 0 from the left side, x is a negative number. But because of the presence of x square, okay na, when x is approaching 0 from the left side or x is approaching 0 from the right side, x square will be approaching 0 only from the right side. Are you understanding what I am saying? If x is approaching 0 from the left side, its square will be approaching 0 from the right side. When x is approaching 0 from the right side, then also its square is approaching 0 from the right side. So for both cases, x square is approaching 0 from the right side only. So we are not finding LHL and RHL separately. We are finding the limit of the function directly. So let me check whether limit x approaches 0 f of x is equal to f of 0 or not. If the limiting value of the function is equal to value of the function, then we can say that the function is continuous. Okay, first let me find limiting value of the function. So limit x approaches 0 f of x. Dear students, you have to understand one thing. These are our basics. X is only approaching 0. X is not exactly 0. X is approaching 0 means x is near to 0. But remember that x is not equal to 0. Okay. Since your input is not equal to 0, instead of f of x, I will write e power 1 by x square divided by e power 1 by x square minus 1. Okay, now since your input is not exactly 0, I will take this particular function. And already in limits at infinity concept, we have discussed that proper fraction power infinity is 0 and improper fraction power infinity is infinity. It is approaching infinity. We have already discussed. In case if you directly substitute x as 0 here, you will get e power 1 by 0. You will get e power 1 by 0. 1 by 0 is infinity. E value is approximately 2.71. 2.71 is a improper fraction. Improper fraction power infinity is infinity. We have discussed in those videos already that if it is in the e power infinity form, we will not directly substitute x value as 0. We will make a small change here. What is that small change? Already we have discussed that we are going to divide the numerator and denominator with e power 1 by x square. So the numerator is divided with itself, e power 1 by x square, and the denominator is also divided with e power 1 by x square. Okay. Now dear students, what do we get here? So it is equal to limit x approaches 0. The numerator will become 1 divided by, this term is again 1 minus e power minus 1 by x square. So after the small change, if you observe, we are getting, now if we substitute x as 0, what will you get? When x is 0, 1 by x square is approaching infinity, and minus 1 by x square is approaching minus infinity. E power minus 1 by x square is approaching e power minus infinity, and e power minus infinity is 0. Improper fraction power minus infinity is 0. Already we have discussed it in our previous videos. Therefore, dear students, e power minus 1 by x square is approaching 0 if x is approaching 0. Now you can directly substitute that value, 1 divided by 1 minus, you will get e power minus infinity, which is 0. So the answer is 1. What is 1? Again, what is 1? The limiting value of the function is equal to 1. Limiting value of the function, dear students, is equal to 1. Now let us also check what is the value of the function f of 0. F of 0, when input is 0, the output is 1. Obviously, it's very clear that the limiting value of the function is equal to value of the function. Since the limiting value of the function is equal to value of the function, we can say that the function f of x is continuous at x equal to 0. So we have verified it. In case if these two numbers are not equal, I would have told that it is not continuous. But anyhow, limiting value of the function is equal to value of the function. Therefore, f of x, this particular function, is continuous at x is equal to 0. I hope you understood this. So let us take next example. Let us see next example. Here is our second question. F of x is given as x into e power 1 by x divided by 1 plus e power 1 by x plus sine of 1 by x. Okay, now when the input is not equal to 0, and the answer is 0 if x is equal to 0. Okay, now so let us check whether the function is continuous or not. Okay, at x is equal to 0. Another question. Here if you observe, when x is approaching 0 from the left side, 1 by x is approaching what? 1 by 0 minus, which means minus infinity. In that case, e power 1 by x is approaching e power minus infinity, because 1 by x is approaching what? Minus infinity. This is taking the value 0. But if x is approaching 0 plus, then 1 by x is taking 1 by 0 plus form, which means plus infinity. Then e power 1 by x will be taking what? E power infinity form, which is infinity. Two different possibilities, correct or not? When x is approaching 0 from the left side, e power 1 by x is becoming 0, and when x is approaching 0 from the right side, e power 1 by x is approaching infinity. E power 1 by x is behaving differently when x is approaching 0 from the left side and also when x is approaching 0 from the right side. For this reason, in this particular question, we have to find LHL if it exists, and we have to find RHL if it exists. Then we have to check whether LHL is equal to RHL, which is equal to f of a or not. Okay, now so we have to check for this. LHL is equal to RHL equal to f of a. But remember one thing, dear students, already f of a means in this case f of 0, because we are checking continuity at x is equal to 0. Now f of 0 is equal to 0. The value of the function exists. By any chance, if LHL is not determined or if RHL is not determined, then we say that the function is not continuous at x is equal to a. By any chance, if we cannot find LHL or if we cannot find RHL, then we say that the function is not continuous at x is equal to 0. Keep this in mind. Now based on this, let us start solving. Let us find LHL. Find limit x approaches 0 minus f of x. I am finding the left hand limit. So limit x approaches 0 minus. When x is approaching 0 from the left side, already I have discussed that e power 1 by x is approaching 0. So I can directly solve this. Okay, let me take the function x into e power 1 by x divided by 1 plus e power 1 by x plus, I am giving limit for this function and this function separately. Limit x approaches 0 minus sine of 1 by x. Sine of 1 by x. Observe one thing, dear students. Here I can substitute x as 0 directly. So 0 into e power 1 by x is approaching 0. 0 into 0 divided by 1 plus 0. The first one will give you 0 as value. But dear students, when x is approaching 0 from the left side, 1 by x is taking minus infinity form. And we do not know, see 1 by x is approaching minus infinity, but we do not know exactly what is that value. So you are getting what here? Sine of minus infinity. don't say that the answer is minus infinity or plus infinity. Sine of any number is a finite value, and that finite value is between minus 1 and plus 1. See, sine of minus infinity is a finite value between minus 1 and plus 1. But we do not know what is that value. We cannot determine this value. See, sine of minus infinity, we will use this concept in many upcoming problems. Keep this in mind. We have also used it in limits chapter. Sine of minus infinity is some number, is a finite number only between minus 1 and plus 1, but we cannot determine that value. This particular value, sine of minus infinity, is not determined. For this reason, since I cannot find the value here, I cannot determine the left hand limit. So what is left hand limit here? It is not determined. We cannot determine the value of left hand limit. Since we cannot find the value of left hand limit, we can say that the function is not continuous at x is equal to 0. Therefore, f of x is not continuous at x equal to 0. Keep this in mind. I hope you understood this question. So because of this reason, since we cannot find left hand limit, the function is not continuous at x is equal to 0. I don't care what is RHL. Of course, if you try to find RHL also, you will get that RHL is not determined. Okay, we will go with next question. Dear students, first you try this particular question, third question. First you try it and then after that you can check the solution. Okay, now so pause the video and first you try it yourself. Check whether the function is continuous or not at x is equal to 0. Okay, so anyhow I am explaining it. First of all, the value of the function at x is equal to 0, the value of the function is f of 0. So 0 minus step 0 is 0 only. 0 minus step of 0 into sine of 1 by 0. Actually they should have given one thing is I cannot find the value of the function directly with this given function, because when x is exactly 0, 1 by 0 is not determined. We cannot take it. Okay, now so let me make a small change in the function. I will take this function if x is not equal to 0, and I will take the answer as 0. Okay, now I will take the function as 0 if x is equal to 0. So I have made a small change in the question. Now clearly the value of the function, when input is 0, the output is 0. If left hand limit is equal to right hand limit, and if it is equal to value of the function, obviously the function is continuous. But why should I find the left hand limit and right hand limit separately instead of directly finding the limiting value of the function, just like in the first example? Because of the presence of step function. Here this is step function, greatest integer function. This is greatest integer function, GIF. Okay, so because of its presence, we are finding LHL and RHL separately. Okay, let me find left hand limit. Left hand limit, if I try to find limit x approaches 0 minus f of x. So which means limit x approaches 0 minus, dear students, by definition, I hope all of you know that. Okay, or let me use this function itself directly. What is that? Instead of converting into fractional part, let me use it directly. X minus step x into sine of 1 by x. Dear students, when x is approaching 0 from the left side, I can write x, what is it? I can convert it as what? H approaches 0. And when I am converting it as h approaches 0, instead of writing x, I will write 0 minus h. X is equal to 0 minus h means minus h only, na? So what do you get? Minus h minus step of minus h into sine of 1 by x. Dear students, I hope you all know how to find the step of minus h. Step of minus h value is 0.000 and so on. Maybe 0.0000 and so on, somewhere you will get 1. Okay, now, and its step is equal to minus 1. I hope all of you know it. Okay, and in place of h you can substitute 0. Minus 0 minus of step of minus h is minus 1. Step of minus h is minus 1. I am dealing these two differently. Here I am directly substituting h value as 0, but here it is step function. I should not directly substitute h value as 0. Okay, now first of all you simplify it like this. Step value of it is minus 1 into, And we know that when h is approaching 0, sorry, here I should have substituted x as what? Minus h, right? Now when h is approaching 0, this is sign of minus infinity. It is approaching sign of minus infinity. This value is 1 and this value is what? Not determined, correct or not? Just in the previous example, I told you that sign of minus infinity is not determined. So the 1 into a value which cannot be determined is equal to what? Not determined. So I cannot determine the value of LHL. Because of this reason, in this problem also we cannot determine the value of LHL. Na? So since LHL is not determined, I can say that the function f is not continuous at x is equal to 0. So I can decide, since LHL is not determined, f is not continuous. I just want you to tell you one thing. Do you think in this problem RHL is also not determined? Let me know in the comment sections. You might be thinking RHL is also not determined in this particular example, but I want you to check whether right hand limit in this particular problem is also not determined, or are you getting any fixed answer. Let me know about it, but it doesn't matter. Since LHL is not determined, the function is not continuous. This conclusion will not change. The function is not continuous. But what about RHL? I did not find the RHL. Na. I want you to find RHL and let me know the answer in comment sections. Okay. It's important. You have to understand the subject. You have to understand the concept. Okay. Fine. Let us go to the next question. Here is your next question. A simple question. They have given f of x with two different possibilities. So if your input is between minus 1 and plus 1, then f of x is equal to this function. And if your input is between 0 and 1, then your f of x is equal to this function. Okay, now. So anyhow, they are asking us to check whether the function is continuous at x is equal to 0 or not. So dear students, the function will be continuous at x is equal to 0 when if left hand limit f of 0 minus is equal to right hand limit f of 0 plus, and it is equal to value of the function f of 0. If all these three things are equal to one another, then obviously the function is continuous at x is equal to 0. And in question also, they did not ask us to check whether the function is continuous or not. What is the question? If f of x is equal to this particular function is continuous at x is equal to 0, which means they told that the function is continuous at x is equal to 0. We are supposed to find the value of k. Okay, now. So which means I can directly take this. Now I can take this, but let me find each one of them separately, then at a time I will take it. What is f of 0 minus the left hand limit? Limit x approaches 0 minus f of x. What is f of x? X is approaching 0 minus means x is less than 0 only. So if x is less than 0, instead of f of x, you should take this function. So take it, root of 1 plus kx minus root of 1 minus kx whole divided by x. Dear students, if you have practiced limits chapter, obviously you will know how to solve this. In case if you are good at limits, automatically you will be good at continuity. There is no doubt in that. Do practice well. So in the topic of limits using standard formula, I told you how to use this, how to simplify this particular expansion. So what I am going to do is limit x approaches 0 minus, I will write it as 1 plus kx whole power 1 by 2. And I will write this as minus what is it? Of 1 minus kx whole power 1 by 2. I will subtract 1. I think this is not needed. No need to subtract anything here. Okay, now whole divided by x. Next, dear students, in the limits using standard formula, we have learned that 1 plus x whole power n can be approximated as 1 plus n into x. I can approximate if x is approaching 0. If x is approaching 0, then I can say that 1 plus x whole power n is approximately 1 plus nx. Let us do the same thing here. So then what happens in the next step? Limit x approaches 0 from the left side. Since x is approaching 0, kx is also approaching 0. So I can write it as 1 plus 1 by 2, the power into kx. That means kx by 2. okay, and with minus, so open the bracket. Students will generally forget to open the bracket. So here also with the same knowledge, 1 minus, the power will be multiplied with kx, you will get kx by 2 whole divided by x. Now let us simplify this. Plus 1 and minus 1 will get cancelled. Kx by 2 minus into minus kx by 2. What is it, dear students? So it is equal to limit x approaches 0 minus kx by 2 plus kx by 2 is kx whole divided by x. X and x cancels, no need of limit anymore, it is equal to k. So dear students, our left hand limit. What is our left hand limit? I got left hand limit as what? K. Now let us see what is right hand limit. Let us find what is right hand limit. So to find the right hand limit, f of 0 plus, I'll write limit x approaches 0 from the right side, f of x. I'll write f of x. But what is f of x here? X is approaching 0 plus means x is greater than 0 only, na? If x is greater than 0, then instead of f of x, what I'll write? 2x square plus 3x minus 2. Here you can directly substitute x as 0 because it is a polynomial function. So 2 into 0 square plus 3 into 0 minus 2. And the value is minus 2. So the right hand limit is how much, dear students? It is minus 2. So left hand limit is k, the right hand limit is minus 2. What about the value of the function? When x is equal to 0, then also f of x is this only. Okay, na? F of, what is it? F of x is equal to x square 2x square plus 3x minus 2 when x is 0. When x is equal to 0, f of x is equal to this function only. So f of 0 is equal to 2 into 0 square plus 3 into 0 minus 2. Here also you will get same value minus 2. So dear students, since the function is continuous at x is equal to 0, LHL is equal to RHL. So therefore k is equal to minus 2. What is the answer for this question, dear students? K value is minus 2. In this case, value of the function is not needed. Okay, na? But anyhow, I hope you understood. Okay, na? We'll go with next question. Here is your fifth question. They told us to find the condition that the given function f of x is continuous at x is equal to 0. Okay, now if the given function is continuous at x is equal to 0, they told us to find the condition. Remember one thing, dear students, the condition will be in terms of a, b. Yes, here also a is there now. The answer will be in terms of a comma b. Remember that. Okay, so whatever constants, unknown constants are there, mostly the condition will be in terms of them. Fine, let us see what is the condition. Since they told that the function is continuous at x is equal to 0, obviously left hand limit will be equal to right hand limit, correct or not? So dear students, limit x approaches 0 minus, what is f of x? X approaches 0 minus means x is less than 0. And if x is less than 0, this is the function. A square cos square x plus x square sin square x. And what is f of 0 plus? That means limit x approaches 0 plus f of x. X is approaching 0 plus means x is greater than 0 only, right? So x is greater than 0 means our f of x will be e power ax plus b. Just to decide who is the function here and here, we need this x approaches 0 plus and x approaches 0 minus. Now you can directly substitute because it is a continuous function, or you can directly substitute x value as 0. A square into cos square 0 is 1 plus 0 square into sin square 0 is 0. So LHS is a square plus 0. It is equal to, what is RHS? Substitute x as 0 here. E power a into 0 plus b, correct or not? So you will get, dear students, you will get a square is equal to e power b. So this is the condition. In case if you want the answer in terms of logarithms, I can convert this exponential form into logarithmic form. And when you convert, what happens? You will get the power b is equal to, the power is equal to log of a square with base c. Log of a square with base c. This is the condition. B is equal to log of a square with base c. This is the required condition. This can be the condition or this can be the condition. And sometimes what they will do is using the properties of logarithms. If you know how to use the properties of logarithms, the power will become the coefficient. So we can say that b is equal to 2 times log mod a. We should not write only a, we should write mod a, because we don't know whether a is positive or negative. So when the power becomes coefficient, we will not write log a, we will write log mod a. So in these three possibilities, anything can be the condition. Okay, now all these three are correct. Sometimes in multi-correct also they can ask this question, correct or not. So let me take this one, b is equal to 2 into log mod a base c. It can, even this answer also can be correct. So this is the condition, dear students, if the function f of x is continuous at x is equal to 0. Okay, we'll see the next question. Sixth question, they have given f of x. F of x is equal to this function if x is negative, and f of x is equal to this function if x is positive, and f of 0 is equal to c. Okay, now they told that f is continuous at x is equal to 0. If that is the case, we should find the values of a comma b comma c. Important model question. Okay, now very important model question. Application of the concept of continuity at a point. Okay, so first of all, since the function is continuous at x is equal to 0, let me find the left hand limit, f of 0 minus. Observe, dear students, if you have practiced limits chapter once again, obviously finding all these limits will be very easy. There is no doubt in that. So what is it? Limit x approaches 0 minus f of x. I should write f of x. And what is f of x? Since x is approaching 0 from the left side, x is less than 0. And since x is less than 0, instead of f of x, what I will write? Sine of a plus 1 into x plus sine x. And let me separate the common denominator here and here. Just to decide what is the function, I should need this. Now I can find the limit of each function using trigonometric limits. We have already learnt, dear students, that limit x approaches 0, sin kx by x is equal to k, and limit x approaches 0, sin x by x is equal to 1. We have discussed this already in trigonometric limits. So therefore this is in the form of sin kx by x, which is equal to k. K means a plus 1. And limit x approaches 0, sin x by x is 1. So what are we getting? We are getting a plus 2. Just to decide what is the function, I need this x approaches 0 minus or 0 plus. After this, we can ignore. We can assume that x is approaching 0 and we can solve the problem. So dear students, the left hand limit is what? We have got left hand limit as a plus 2. So remember this, f of 0 minus is a plus 2. Now let us find the right hand limit. Let us find the right hand limit. F of 0 plus means limit x approaches 0 plus f of x. Who is f of x now? Here x is approaching 0 plus means x is greater than 0 only, right? Who is f of x? When x is greater than 0, f of x is this person. Instead of writing f of x, I will write this person. What is it? X plus bx square whole power 1 by 2 minus x power 1 by 2 whole divided by b into x power 3 by 2. Dear students, already we have discussed these models in limits chapter. In which video? Limits using standard formula. Okay, now so please check out in case if you are confused how to find these kind of limits. It's very easy. I want to use this form. What is it? 1 plus x whole power n form. Because 1 plus x whole power n is approximately written as 1 plus nx. So that the solution becomes easy. For that reason, I want 1 plus. I want 1 here. For that reason, I will take x common in these two terms. In these two terms, if I take x outside the bracket, it will also take the power. So limit x approaches 0 plus. Here and here I took x common, which becomes x power 1 by 2 into 1 plus bx whole power 1 by 2 minus x power 1 by 2 divided by b into x power 3 by 2 can be written as x power 1 plus 1 by 2. Power 3 by 2 can be written as 1 plus 1 by 2. Then you can split it like this, x power 1 into x power 1 by 2. Using a power m plus n, okay na, which is equal to a power m into a power m. Okay, now you can take x power 1 by 2 common in the numerator and you can cancel this with this x power 1 by 2. So after cancellation, after taking x power 1 by 2 common and after you have cancelled this x power 1 by 2, here 1 will be remaining. Correct or not, dear students? Fine. Now let me use this form. 1 plus x whole power n is approximately 1 plus nx when x is approaching 0. If x is approaching 0, our bx is also approaching 0 only, na? So I'll write what? In the next step, I'll write it as limit x approaches 0 plus 1 plus n into x. That means you'll get bx by 2 minus 1 whole divided by bx. So plus 1 and minus 1 gets cancelled. Bx 1s are and bx will get cancelled. You will get 1 by 2. Dear students, the right hand limit f of 0 plus is what? F of 0 plus is 1 by 2. And already you have f of 0. What is f of 0? It is equal to c. So you know now left hand limit, right hand limit, and also the value of the function. Correct or not? Now, dear students, since the function is continuous, according to the question, the function is continuous. I have erased that part. Since the function is continuous at x is equal to 0, we can say that f of 0 minus is equal to f of 0 plus is equal to f of 0. F of 0 minus is a plus 2. F of 0 plus is 1 by 2. F of 0 is c. So directly we can say what is c value. What is c value, dear students? C value is 1 by 2. Now, how will you find a value? By equating these two. A is equal to 1 by 2 minus 2. So a is equal to 1 minus 2 2s are 4. With common denominator 2, you will get minus 3 by 2. So I got a value as minus 3 by 2. We got only a value and c value, but we did not get b value. What is the meaning of it? Means b can be any real number, but b is in the denominator in this function, so b cannot be 0. So therefore, dear students, b can be any real number except 0. So we can say that c value is 1 by 2, a value is minus 3 by 2, but in the solution we did not get any b value. So it means that b can be any real number except 0. This is important, except 0, because b is in the denominator in the given question. Okay, now, so this is the answer for this particular question, dear students. There are many more problems to solve in this particular concept. Let us solve all the remaining problems in next video. Okay, now, so I hope you understood the concept of continuity at a given point, and I hope you have understood how to solve these problems. Let us learn more problems on this concept in next video. Until then, this is M. Sandeep Kumar, and I hope you enjoyed this particular video. Do like it and share it to your friends. Thank you, dear students. See you all in next video.